In this video, I focus on a little interface that I've made that goes between an algorithmic drum machine made in Max and analog modular drum modules that use momentary trigger control signals of approximately 5 volts to trigger the analog sounds. I'll show the construction of the interface, the connections to the drum modules, and the relevant parts of the Max patch. The interface here is a separate box that contains an Arduino Uno microcontroller with the digital output pins connected to 3.5mm jack sockets on the one hand and banana sockets on the other hand. They're connected in parallel so that I can use it for Eurorack or Serge modular simultaneously if I want. On the Serge side, the earth also has to be connected from the interface to the Serge using a banana cord. So inside, across each digital output, I've put a 1K resistor here in series with a LED to earth. So there's the LED going to the earth. The LED shows the beats as they appear at the interface. There's no other hardware in the box, and all the soldering of the LED and resistor components are done straight on the back of the sockets. So output from Arduino to the socket, resistor, LED, connection to earth. I'll just put it back temporarily like that. Now here I have the interface connected to 2 Eurosynth modules, here and here, each making 2 sounds, and a clap-like module, like a clap-like sound made on the Serge by enveloping an oscillator. The oscillator is frequency modulated simultaneously by 2 types of noise, pink and sample and hold. So 5 sounds in all, although the interface can trigger up to 8 sounds. So I've got 4 sounds on the Eurosynths and 1 sound on the Serge, 4 connections to the Eurosynth, 1 to the Serge. So if I put the sounds into operation, start here with a kick, and now you can see the kick and the snare on the LEDs. Close hi-hat, open hi-hat, and the clap-like sound that's being produced by the Serge. And you can see the LEDs flashing on the interface accordingly. Okay. The interface receives the drum beats from the computer via USB, which is coming in here, using standard serial protocol inside Max. The drum beats are transferred all at once to the interface as a single number of type unsigned char, that's to say 1 byte, that has a range from 0 to 255. When one of the beats appears or disappears, the number is simply updated to reflect the current situation. Let's look at the patch in Max. This is the function that combines the bits from the algorithmic drum machine. First, when the bit arrives from the algorithmic drum machine, it's turned into a one-shot using this function here. It turns on the value 1 for a fixed duration, and the duration is half the beat length in beats per minute. We can have a quick look inside that to see the inside of the one-shot. It consists of a message and a line object. Once it comes out of the one-shot, it goes, all the ones and the zeros are combined together in a pack object. That's a pack object with a PAK, into a list of 8 digits here. Then the final value from 0 to 255 is created by using a regular expression, expra, where each bit is multiplied by a power of 2 according to its rank in the unsigned char. So you have 1 plus 2 times 2 plus 3, that's to say the argument 3 times 4, argument 5, 4 times 5, argument 4 times 8, argument 5 times 16, and so on. Finally, there's a change object that makes sure that repeat values are not wastefully sent to the interface. So if I switch the beats on again, you'll see the number being created here in the list. This is the final number that's being sent to the interface. The single char is sent to the interface using the serial protocol, which we can also have a look at. It's in here. In this module here. So the 8 bits created to the char, and then it's sent using the serial protocol to the interface. Serial at a baud rate of 57,600. That's about twice the normal rate for MIDI. So it updates pretty quickly at the interface end. Hope you enjoyed this video. Thank you for joining me again.